topic is about scientific notation. The way scientific notation works is that there is a base number between 1 and 10, which is then multiplied by 10 to the power of an exponent. I'm first going to show you how to convert from a regular number to scientific notation. The exponent for the 10 is equal to the number of times that the decimal must be moved to the right or left in order to produce a base number between 1 and 10. So let's look at this number, 324,000. The first step is to figure out how many times we need to move the decimal left or right to get a base value between 1 and 10. So currently the decimal is at the end of 324,000, and in order to convert 324,000 to a base value between 1 and 10, we actually have to take the decimal that's all the way at the right and move it 5 places to the left in order to get 3.24, which is a number between 1 and 10 as the base. In this case, that number is 3.24 instead of 3.24000 because we want to keep the same number of significant digits in the base as we had in the original number. Because we had to move to the left 5 times with our decimal, this means that our exponent for the 10 has to be 5 as well. So let's look at another example. We have a number where the decimal is currently to the left, and we want to move it to the right in order to get a base number between 1 and 10. Here, we need to move the decimal to the right 3 times, which will make our base number 8.16. Because we moved the decimal 3 times to the right, the exponent for the 10 will be -3. Also, we want to make sure we keep the same number of significant digits in the original number and the number after scientific notation. So to find the number of sig figs of a number that's written in scientific notation, you only look at the base and you ignore the 10 and the exponent. Now, what if we wanted to go from scientific notation to a normal integer number? Now, it's almost like doing the opposite of what we just learned. First, we look at the exponent of the 10, as that will tell us how many times we need to move the decimal. Now, for this particular case, if the exponent is positive, you move the decimal to the right. If the exponent is negative, we move the decimal to the left. To turn 3.24 times 10 to the 5th back to our original number, first, we see that the exponent on the 10 is a +5. So we're going to take that decimal and move it 5 places to the right. When we do this, we arrive at our original number of 324,000. Now let's look at our other number. We currently have 8.16 times 10 to the -3. Now we see the 3 is negative as the exponent, which means that we need to move our decimal 3 places to the left. When we do this, we arrive at the original number of 0.00816. And that wraps up our first unit in general chemistry. If you have any questions, you have plenty of ways to reach out to us via email, our website, our Instagram, or you can simply drop a note in the comments below and our team will be sure to get back to you as soon as possible. And we will see you again in the next episode.